Hello and welcome here to the SUSECon 2025. In this session, we will show you a little bit how to effortlessly deploy SUSE Rancher Prime with tools like Terraform, Ansible, Helm, and RKE2. Our today's agenda are the challenges, how especially Terraform and Ansible can help us automate the first deployment of SUSE Rancher Prime. Then we will take a quick glance at the abstraction layers to easily automate all the stuff for multiple hypervisors or hyperscalers. And then we will show you a little bit about the deployment architecture of our automation. That's me, Tobias. I'm the integration team lead of Adfinis Germany. And I have with me my colleague Noah, who's a senior DevOps engineer at Adfinis. At Adfinis, we are an open source company, and since 10 years, a big partner of SUSE. We support all of their tools. We deliver 24/7 support with our colleagues in Australia. We have a motivated team who burns for open source and for all the new technologies. And yeah, now we're here to show you a little bit how we automate SUSE Rancher Prime. Well, when we come to the customer, one of the initial problems we face is a little bit like the chicken and the egg problem. Rancher is a real cool platform to manage Kubernetes, but to run it in production, you need a Kubernetes cluster to run Rancher on it. So that's the first problem. You need a Kubernetes cluster to run Rancher, but without Rancher, it can be hard to implement a running Kubernetes cluster for production environments. Often in our experience is that Kubernetes experience in the companies, or especially in the public authorities, is not that big. So the manual creation of a Kubernetes cluster that is suitable for production rollout, like SUSE Rancher, is complex and can be hard to maintain, especially when there's no personnel who has appropriate knowledge of Kubernetes. For us, on the other hand, as an open source company who supports the customers in deploying the SUSE Rancher Prime and managing their cluster, we have to keep in mind that a lot of the customers have different environments. They have different proxies, different firewalls, different hyperscalers, different network topologies. All that are things we have to keep in mind when we want to automate it so that we can easily adapt to the different environments.
So that's where Terraform and Ansible comes to the rescue. So let's have a first look at the Terraform part of the whole thing. We are currently trying to evaluate or switch from Terraform to OpenTofu as an open source service provider. We're currently looking into that in the German team. But Terraform and OpenTofu in general are great infrastructure provisioning tools, as they have multiple multi-cloud and on-prem support for different providers. So we are free from the provider side and can provide multiple providers and support in that regard. We have a state management, what means we can track the resources and stuff we deployed and have a consistent infrastructure view in a central place, and can use, for example, S3 to manage all that stuff. It's highly scalable and reusable, so we use modules we can reuse in different environments, for example, like for object storage in general, or for VMware in general. So it's highly dynamic and reusable for us, and it's really just a cool concept to be able to reuse all the things you already did and do not have to redo it and manage all the duplicate code, for example. And it's really great integrated with our pipeline. So if you commit something, it's just in a few minutes it's rolled out, and the infrastructure deployment is part of the whole workflow and integrates seamlessly. Let's have a look at a site that's after the Terraform deployment. So as soon as the VM or the resource is spin up, we are able to use Ansible to deploy the stuff we need. In that case, it's RKE2 we need. So we use Ansible because it's agentless and we just need some SSH agent running on the system where we can log in, and that also reduces the dependencies we need for the deployments. We then use the simplicity of RKE2 and just spin that up using the Ansible playbook for RKE2. And that configures all the things we need and spins up the component used with RKE2 in the correct version. And we even have health checks implemented and can use the RKE2 Ansible role to spin up the whole workflow with that. We then use automated Helm charts deployment to deploy, for example, Rancher and other services we need for the whole integration. And in our case, the security policies and the sysbench benchmarks can apply automatically, which is great for a hardened system and for the whole security concept. The whole execution is predictable and can be rerun. That's the beauty of Ansible. And we have multiple tasks and checks to check if the system's correctly running. And we have even a zero downtime deployment possibilities to manage the system updates in later steps. So after Ansible is deployed and the playbook for RKE2 is rolled out, we have the ability to roll out all other things with Helm. Helm is a great tool to use Kubernetes in general. So we have the ability to use existing charts, for example, like Rancher, and deploy all its dependency with it. So like additional tools like monitoring and all that stuff are automatically and repeatable deployed. So Helm charts are great to roll out multiple tools to Kubernetes, even with versioning and rollbacks possible. So that ensures even if something is going wrong, we can go back to the old version, for example. And generally said, RKE2 is also a great tool to get it easily up and running the whole system, because you just have to deploy the binaries and that's running perfectly, even secure, like with the CIS compliant out of the box and multiple other improved security aspects. So we have a hardened Kubernetes distribution here. As I said, it's really simple to get it up and running, and it's even optimized for Edge and Enterprise. If you cannot use K3s, for example, you can use RK2 even on the Edge because it works well with air-gapped systems, and it's even there FIPS compliancy and all that stuff.
Yeah, so thanks, Noah. Now I will take over again. We will take a quick look at the abstraction layers we implemented and use in our automation. So the main part of this is to define clear responsibilities. So, for example, we already knew that we had to roll out SUSE Ranger or the initial RKE2 cluster to different hypervisors. Especially our customers use vSphere and Nutanix as their hypervisor, so it was for us clear that we at least need those two. We have now other customers who use, for example, OpenStack, who also has a Terraform provider, so it will be then easy for us to integrate the other hypervisors, since in the current state, all that Ansible needs is a hostname and IP, how it can reach the created virtual machines. All the other configuration is handled inside the module. So, for example, we rely normally on Cloud Config, which is supported by vSphere and by Nutanix. When we have other hyperscaler, we need to check what is usable, but most of the hyperscaler support Cloud Config, so we can use the Cloud Config to give the initial configuration of the VM directly in the Bootstrap process. So, for example, the hostname, the IP can already be set during Cloud Config. We can also specify a dedicated automated user for Ansible with an SSH key that is automatically created by Terraform and will then be later used from Ansible to connect to the VM. And with that, we can easily switch out the VM provider, I would call it, because all that we need is a module that outputs the hostname and the IP address, ideally in the with the same output variable in Terraform, so we can then easily switch out the modules. We could even make a mixed deployment, and let's say, hey, I have two VMs on vSphere and one on Nutanix. That's also possible if the infrastructure would be in that way that they have vSphere and Nutanix, for example. We're doing the same with Ansible. We normally don't use tasks directly in the playbook. We normally always have roles, for example, a role who builds us a dynamic inventory based on the information we get from the Terraform modules that create the VMs. And then we have a Terraform module who runs the Ansible playbook, who takes care of all the additional variables and the SSH connection and all that stuff. And with that, we are now taking a look at our deployment architecture. Well, that's a little bit of a recap that we had previously. So we have the Terraform / OpenTofu for the infrastructure related tasks. So everything we need to do on the hyperscaler or around the infrastructure, like the creation of the VMs when we need to create some networks on the hyperscaler or the hypervisor, when we need to add tags or separation rules on the VMs. That's all done via Terraform, because Terraform is really great for everything which works with an API. And on the other hand, we have then Ansible, who works best for configuration management, for all the post-configuration stuff that you can't easily do with an API, for example, like installing RKE2 on a VM. So we use Ansible then for the base configuration, like DNS, NTP, certificates, proxies, all that stuff that are important in an enterprise environment. Also, the hardening of the VM with specific roles for Ubuntu, for Red Hat, Linux, or for other derivatives of Linux. Then we will start the rollout of RKE2 with a specific role, and will afterwards roll out Ranger, Cert Manager, and additional tools like monitoring and log operator to forward logs to a central logging system and all that stuff. And afterwards, we switch back to Terraform and start to pre-configure Ranger, for example, to configure all ready the single sign-on, to adapt the branding to the customer's wishes, and for example, also create already some cloud credentials or some other initial configuration settings. So here we have this whole thing now in a graphic format. So we start with Terraform, which will then create, for example, in the normal deployments, 3 VMs. For example, on the VMware vSphere hypervisor, here we have some templates which we will need or which we will use, which will then create 3 specific Ubuntu VMs. We will then use Terraform to create an Ansible inventory and run the playbook. So Terraform will run or will execute Ansible, will provide the inventory, will provide the hosts, and some special variables and some special inputs like the SSH keys, how to connect, and all that stuff. And it will then also do all the deployments of RKE and of Rancher Prime. And when we are done with that, we will use the kubeconfig that is generated from the Ansible playbook, read it in Terraform, and we'll use it to configure Ranger after the rollout. So are able with our automation to configure all the stuff that the Ranger provider is capable. For example, to configure already the SSO so that the user can, from the beginning, log in with their LDAP users, or with some Keycloak integration, they can use then their Keycloak login to log into Ranger. We can use the branding so that SUSE has or Ranger has the company color, that the specific logo is there, or that they have some banners for production test, whatever the stage is the Ranger is currently running, for example. But we can also do stuff like already create some cloud credentials so that user can start log in, create some clusters, for example, on the VMware vSphere hypervisor, or we can integrate with all the other resources that are possible. Earlier, we had some modules to already create RKE1 node templates. This is currently not anymore in use since all of our customers use RKE2. And that's the part how we roll out SUSE Rancher Prime initially to our customers so that they can then start creating their downstream clusters and run their workload on Kubernetes. So thank you, and I hope you enjoy the SUSECon 2025.